Uh, okay. Whenever you open this YouTube or Netflix, you see this type of page. This type of home is free. So how it's come? Any idea, guys? How it's come? Uh, Yes, machine learning behind these things. Yeah. So now, how we can build this type of system, which just show here the most relevant videos, so that we are going to see how learning. But before that, let's understand why this screen here these relevant videos are important means these relevant videos are also known as recommendation itself. So why we use recommendation system is why we have even some these topics. Let's focus on these things first. Just give some thought experiment. Let's suppose you open YouTube and you will not be seeing this thing. You will be only seeing the search bar. There will no video suggestion for you. Then you will be experience it will be pathetic, uh, boring, means people will not be sticking to the YouTube. Yeah, YouTube will have failed if there will not be any sort of recommendation system. Video suggestion YouTube could have got a failure. So this thing is very important. So that YouTube suggests you the right videos, so you don't have to search anything like Google. You do themselves tell you what you are going to see, because it is also saying that I have mentioned it here the numbers. So yeah, so around 50% of traffic of this YouTube, 80% of Netflix comes from the recommendation itself. Means people don't come with the mindset that they will watch this movie, this video. They just come to the platform from the recommendation itself. They just click something. So far from the recommendation itself, the 50% to 80% traffic of this platform are coming from uh, recommendation. And it is not only about the YouTube. So even if you see like Instagram, in Instagram it is all about recommendation. You just keep sweeping up the reels, what the next field to show you the that's all about recommendation system. You got to Spotify. People don't like searching a specific song. Most of time after one song, what the next song will be played. Recommendation system generating a playlist for you. Recommendation system Amazon. On Amazon homepage you see like a lot of recommendation itself. Here the 35% of shoppers are buying from the recommendation itself. You just name the platform, you will find someone recommendations system there. Yeah, so that much important is recommendation system is even there are some platforms us which are not about such entertainment shopping on all which educational platform. Even there you see like Udemy. Yeah, Udemy is also they keep suggest to you of the course the homepage itself. So that is like a power of recommendation, that they take you to the right course. And also it is totally like the backbone. It is everywhere. This every platform has some sort of recommendation. Every bigger platform we can say okay. And I have given you the statistics like 80% of the people watch on Netflix come from the recommendation system. And even as per McKinsey study, it is a latest study that recommendation in your market that is around about the 6.8 billion dollar. That is going to be around 5 times more is coming years. In next 5 year it is going to be like 3 or 5 times more. Also as per study, it has shown that average like 50% revenue has been increased by the recommendation system itself. So this study itself show that how important it is know about recommendation system, and recommendation system is going to be more, is going to have a more bigger market, and it is going to be mostly everywhere else. Means we are saying everyone is trying to integrate some sort of the recommendation into their platform. Even ChatGPT, although it work this machine learning, they were also now it's suggesting some sort of recommendation, like that first message to put all you, and say you said like food delivery, and food delivery also Zomato like. So I think it is enough to make you guys understand like how big is this recommendation system. It is how is going to dominate the future also. The right now it is a also big part in your future. The market going to be expanded more as per maximum studies. Okay, so now let's see what recommendation systems really look like. uh, so let's see. Okay. So suppose you are a user and form a recommendation system. Here we are talking about recommendation system of YouTube and Netflix, all those. Uh, but this uh, principle will be applied in some form of all other type of recommendation system also. It is very important to know about this recommendation system. So it will just be like a principle, a principle, a general knowledge you will get about recommendation system. But now let's focus on this video recommendation system. Okay. Here we will learn the general principle, so that this video recommendation system is so suppose the user has come, and then the video recommendation system is to the home. It is the suggest the topic users which is also already going to be watching. Okay. So the simple overview of recommendation system is so for the given user, we have to predict this top 4 videos, top 4, top 6, top 8, whatever. So we have to predict these top case videos here. So that is the whole goal of the recommendation system. uh, Now how we will decide that what will come into this top 4 videos, like top 4, top 6, whatever. But how we will decide that what will come into this top we will shown on the home screen. So you guys, we can give such idea in a chat. If I talk about the some ideas, some maximize the number, the number of user clicks. So suppose we are saying that the videos which can make the user that will should here in the home page, yeah, but should be visible here. But the problem is this of approach, like maximizing the number of users clicks. Lots of YouTuber these days are creating clickbaits. So with clickbaits, if clickbaits will be prioritized more by our recommendation system, which might be user will stop using YouTube that much here, like people will not stick. So only checking this number of user click for our this top k videos, like it will not be event. Now second point is that we can check by metric that number of complete videos, like whatever been suggested as by the recommendation system top like k videos. We can just see what is the total number of videos like completed. But this type of metric is also having some issues. This recommendation system is arresting some sort of educational videos which people complete. Yeah, but people don't escape, like people usually complete it after some time, like they put in watch later and all. But after only come making the video recommended here, which people will complete like the educational videos and all will not make the YouTube platform. We will also work on the dopamine factor. So only just is making like suggesting videos which user will complete, that is not good metric. So we can see like means we talk about number of clicks, this number of complete videos. There is just one single criteria which is going to be a recommended system. We have to decide multiple criteria, like suppose user like button, that is one criteria, or user was half of the video, that is one criteria, okay, or overall the platform time has been increased, that is also one criteria. So we have taken a multiple metrics, obtain it, and base it on that we will decide what is the recommended videos. So here, suppose for our system, we are taking user press like a button, user was half of it. So such type of matrix we are taking as of now, not only this independent metric like number of plays, because independently taking this metric only could harm us you, as I have explained okay. So now you can come to know that what type of metric we will use to identify whether the recommendation system is it. Uh, a whatever recommendation videos a good or not, there so is the user pass like all, but how we'll know that what is type of recommendation system, and we will okay. So far using that thing first, we are going to see like that sort of a recommendation system. We have option like so recommendation system are of two types. One is personalized, one is rule based, so rules. So not having anything to do with that, machine learning is more of like programmatic recommendation system. So we will not talk about that. We will this personalizes one, okay. You past history also we can consider, means there could be multi like there could be multi factors. Say I am taking only this, there could be a multiple factors only which could be game by the model, means machine learning model. We will just try to game it, and I try it to provide only clickbait videos. Yes, so don't try to take that type of metrics. Okay, now coming to this type of recommendation system, we're going to talk on personalized one. So in personalized one, in this concept based filtering matter. So let me explain what is it. Let me just open the whiteboard. So uh, so every video has some feature, okay. Feature like we can say that okay type okay, you will come in a genre. We can say actor like you. So every video has some features, okay. Feature like we can say okay type, or okay will come in a genre. We can say actor, okay, like who is the actor, director, this type of features also, okay. What else you can say about like what's your duration, okay, 1 hour 30 minutes, and also lot of future videos will having, and same way our user will be also having the futures, and the user future will be have what could be the user future, guys. Each user age has a demographic like what the user is living, and all here suppose here, okay. So uh, is this is the location demographic, okay. And what else could be user future. So we can say that about like age, and we can say also like the user watch time, use the current time. We can say like right now user in which current time, uh, it is 9 to 5 p.m. zone or it is midnight zone. Yes, so based on that we can just consider like user and base it. So on that we consider recommendation also. Yes, so this is just a sort of example features I have considered it of a video the users, and now we can just match these things. Okay, match the specific user with the specific video. Okay, so then we will know that this type of future video feature like a specific video features is like by this type of user. Okay, so suppose whatever the example feature will be that will be lagged by this type of user, so we can map their future. Okay, so this is known as collaborative filtering, where we are just gathering the future of both, and we are just matching a rough explanation. So I also created a proper diagram, so that will make things more clear. So this is what you suppose user a watch a video X and video Y. We have seen that this user is having some features as we discuss, and it lagged with a video X and video Y, which is having some common feature. Okay, so based on that user may like video Z because video Z is also having some similar feature like video X and video Y got. This is known as content based filtering. Clear as this is just a overview. We will go in more detail, but it is clear till here what is this content based filtering is. So basically you are just checking that a proper which have specific feature. If we like this video X and video Y, then he would be like future like this video Y. And okay, now talking about some of the pores of this method, it recommends new video immediately from their content. Means once the user I have the platform, so it automatically suggests a user some videos like suppose I have log in with is Kongi native mode in YouTube. We can also log in with incognito mode, or even in Netflix. Suppose I log a new user itself here. So there, as we know that user future, this video feature we can just suggest the specific videos even we don't have any history of the user interaction. Here we doesn't have any interaction history, but user feature. So we have seen okay like over the past time this type of user from India, which coming specifically from this North India or specific age, they like this type of video. So they will we can just suggest those type of videos only to that user. So this is one of the benefit. Don't we have too much of our data to the user. Even if user we can suggest the video. Okay, another is that like we are just mapping user future, and a video future is also personal, means making the suggestion more personalized. Like it says okay, like once the user is logged in, it can see just okay that also the user future user interaction history. It can keep the videos. So suppose you watch XY video, suggest some sort similar videos, like so it work in both ways. Like once user knew also, and once is watch something, so that interaction history also goes with the right future. And based on that it can suggest the videos, but user will someone has then user will not available in case of cognitive user will be in case of cognitive, but still like for the system that will still user is like some of the sort noise user with a specific feature like demographic location here. Okay, now coming to the cons of the future. As you can see like it only suggesting videos based on what user future is, what is or might or what is user has previously. So here so only based on that it is suggesting. So there is some sort issue with this thing. So can you guys tell what could be issue of this method? So the major one and major problem with this method is that like suppose you are a user and you have gone to YouTube and you watch these machine learning videos. Okay, so you have watched multiple machine learning videos. Okay, so now it sees that you watch this video, which of the machine learning type videos. Okay, now it sees that you watch these videos watch these videos which of the machine learning type. So it will suggest to you machine learning type. Okay, that will be a problem. Now if you suggest this YouTube screen, here we all videos are not similar type. So if YouTube will always suggest to you machine learning with what want a diversity also, but this type of algorithm content based where it is going, this will just show you videos based on your future and the video future here, user future, videos future. So it will not be capturing those videos of our diversity thing. Yeah, it will just try to look similar for videos, so that it is a bigger problem with this approach. Okay, so okay, another problem is this approach, that is we are discusses like future to know about videos. These futures like suppose even not suppose like how many videos on YouTube, it will be in billions. Yeah. You can't just generate this future from the videos. For billions of videos you require some sort of domain expertise first, and second, even domain as domain expertise will require lot of time to create these things, and third, that processing time will also be a slow case, because there are a lot of future will create. And suppose some future is like you transcript. So there is a 1 hour video, so the transcript will be much long. Then this future processing will be more taking time. All that's why this is support type of method doesn't work in some sort of like where we have a lot of data where latency matter to us, like we want to instant calculation for this our recommendation system. Okay, so future engineering we have to do for every future. And second con was that it will be having redundancy problem. So new interest or novel content will be there. Okay, so this was the content based filtering. So from this chart, this was the content based filtering. Now coming to collaborate filtering. So this collaborate filtering, so this collaboration, now you guys can see this chart. I think from this chart itself can be little clear. Okay, then I will explain it. Just watch the chart for some second to make a guess. Okay, so we discuss that the previous method is having the problem of this no novelty, no type of content here, because it is just keep matching the same sort of content. But here you will be see, let's suppose a user has arrived a platform, and user B was an old user. So user B would be having this watch history of video, After that user B was video Y, and after that he was video Z. Okay, so now here we also like user uh, A has watched this video X and video Y. Then the next video we are not going to tell by the future, like we are not going to tell by the future means like this video X having some futures and video Y was having some futures and a video Y which is similar, but this video change we are not going to find that is having similar future like video X or video Y. But instant we are going to see what other user who were having the similar feature of this like this B and user B for having some similar feature and little a similar user, so that we we so that what others we are having some similar feature like user A watch after two videos. So suppose this user B is having similar features, so she has watches this video J, so then we will suggest it video so this user A also. So here this video again repeating guys, this is not based on the future of this video X and video Y. It is not having similar feature, it is not similar content. So for example, suppose I have watched this machine learning video on this linear regression, and then I have watched this machine learning video on logistic regression. Okay, so then it will be suggesting me video, this above method will be suggesting me video of this name bias. Yes, so those who don't know about these names like are just normal algorithm this machine learning. So suppose I have two videos of machine learning, so then if it will suggest me third video also of machine learning, so it will give me that much of dopamine hit here, like a platform should be engaging. So what we'll see, the user be also these two types of machine learning algorithm. So technical show means some sort of the Silicon Valley Python and a Pantheon or other type of technical show or movie we can say, suppose like Terminator. So these are more of movies that these geeks watch here who read this AI and all. So from here it will suggest okay, so this type of new content we can show that a user B has gone to after this. So it will show the same to the user A. Okay, got it. It is clear what is this collaborative filtering is, how it is different from the above one. Okay, cool. Now taking about its pros. So its pros is that it doesn't require any sort of domain knowledge since it learns slowly from user video interaction pattern. What I learns, it means doesn't require domain knowledge. So if I go here, so here for getting the videos of future like this genre, titular, actor, director, and all these things are not directly given in the video description and all might be here. So it require domain knowledge. So just gather this future here, and that is very much of time taking process. But this is collaborative filtering matter. In this collaborative filtering matter we doesn't care about the would you future, we are just caring about the user future only. uh, in this we care about both user future and voodoo future. Here we are caring about only user future, and we are gathering the data from this another user history. We are just providing citation from another user interaction history. So here we don't have to just care about, so we don't require any sort of a domain knowledge. Clear. Now another pose of it, it can uncover new interest by recommending what similar user are engaging with. So as we say that previous one keeps suggesting video similar type of, it is working based on the future, like this video having similar future. So it will just try to find this another video of the same future, but here it is not a case. So that's why it is able to suggest something new. After machine learning algorithm, it can suggest you this some sort of avenger or some sort of cool tech movie also, like Ex Machina, also good movie. So it can suggest to you some sort of new random things, but still it will be relevant to you, it will be relevant to you, but it will not be think like boring, you just continue the same sort of the pattern of the other videos. So some sort of diverse relevant thing. Another third point, that is the pro of this method, collaborative filtering matters, that it doesn't require that much of a compute here, because as I told that it doesn't focus on this future generation training the model on these things. It requires too much time to train the model, even the influence by influence. I mean, running the model here. Influence means running the model. So it is a time taken process. So that it is not case with this collaborative filtering matter. So this content paste filtering matter above one. This was more of a time taken slow matter, as it was considering future, but it is a faster matter, it doesn't consider this video future. So these were the pros. Okay, it is clear, guys. uh, okay, now what are the cons of this, guys? Just think by yourself, like the cons of this method. It for user a, it require user A require user B be there. And suppose you have started a competitor of YouTube, and you don't have any data, then this method will fail, because it for a user A wants, there should be some user B already in the system, who has already watched some videos. So this is a problem. This notes as a cold start problem is machine learning world, because we don't have enough data here. So this is this con of this struggle, that the cold start problem, new user or video like interaction history for recommendation of got it. And the another corner of this thing is like that, suppose I watch very specific type of content on YouTube, which doesn't have lot of interaction history with each other user here. So suppose not me, suppose someone was sought of a specific content here, and some was interested in the specific content and all here. So there is not much of the user that watch that things, and all means there could be scenarios like this here. So then we are again just facing problem with sort of a lack of interaction history for a new type of content. And here niche type of content, we can say. So that is also one of the con. Okay, clear about this pros and con. Okay, so guys, we can see both method, content based filtering and collaborative filtering, is having the cons and having the pros also. So we can just go with new method as at will. Bad of the recommendation here, because it is having some flaw. So what we can do, we can combine both of them, that is known as hybrid filtering. So we can combine both of them, that will just give you the best of the both world. And this is a hybrid filtering that is based YouTube also, even by the Netflix also. So this is some sort of industry matter, and how we are going to combine it. So suppose here we got our inputs will be this user future, videos future, and first we are going to this collaborative filtering base matter, and then we will go to this content based matter here. So collaborative uh, filtering this one and this content base. Here we will go the recommendation, so we just combining both. Okay, right now it will not be clear. I will show you at the end what I mean by this thing. uh, just think like we are combining the best of both world. First we are just create this model of this collaborative filtering. Then we will create the model of this content base, and then we will try to see how we can combine the both here. Okay, before that, here come comparison chart to revise that we have covered, so it will make things more clear. And then we will go on this data collection process for building the model. Takes some second to revise this guys, so I will give you the question answer, so hold for the end here. Okay, so up till now everything it clear till here, because we are going to get into a little tricky part, but daddy will give you more insight and make the things more clear. So before that, just everything is clear here. Okay, so Sushambir point is what when we say domain knowledge. So domain knowledge is like this. Suppose you have to create future of video of some sort of a movie. So how you do it without being an expert in this movie direction and this type of movie world? Like how you will know what type of future this video is having. Like suppose it is this movie is of like for this sad type of audience, or it is having very much of an action type of things, and all these type of things are domain can expert can better a drive from this content. And here like what should be the future, and here could be even more uh, one more complex future. This is the normal category things we are require domain expert. Okay, now so just quickly going into this model building. Okay, so we are going to implement this hybrid category that we require domain expert. Okay, now just quickly going into this model building things. Okay, we are going to implement this hybrid things, and in that hybrid, first we are going to implement this content based recommendation. First we are going to implement these things, but for the we are require the data. So normally we build this machine model. So we do like prepare the data, and when we prepare the data, we have a lot of data. From the data we select a specific column, specific feature which are relevant for our model training. Here we also suppose we having data for this video. So here we can see video data will be video. I will the lengthy, how much is lengthy, and seconds all. Tag the videos. So while someone upload a video to YouTube or Netflix, they put these tags here. It will be blog, family, car. So what type of videos here? It will be also a videos, likes and views here. So suppose this type of data where I don't know what these things I creating problem. Okay, so this type of view data we are having with these columns, and user data will be having some, as I told you, for futures. This column and user data, like ID, we are having username, age, enter, city, country, language, time zone. So user data will be also having or collecting whatever you can say. Okay, then we will be having some data of the user and their interaction here. So like in interaction type, interaction value, from which location they have interacted, and all okay. How much you can how much is that is specific at specific time, is time they just have interacted and all view. So this type of some sort of the noise data will be also having of user we do interaction. So you can see here a user video id, okay, then between this user a video id, between this we do what is interaction, impression, watch, click, search. So suppose someone has searched the specific video by this keyword, basic on clustering, and from which location person search, what is timestamp, what is a specific time is a stamp, that person search here day and night and all another. So these things can comment which has commented on the video. This is comment to user has put a specific location, specific time. Okay, so this type of video, this type of user interaction data we are having, but we can't pull up the data to this model. Here we have to select which are parameters that really require for us, like for suppose suggesting a video to the user which are not considering this video views. Suppose we are not considering because sometime this video also now, if we can't just go by the likes and views of these things here, even on YouTube we will see you not, and you don't always see some sort of a flow, video is, you have a platform, will you be only be the likes, it will not be optimized platform, because the new content having less will not be. So the view, okay, so exactly we are considering video duration, language, a title and text. So video duration length is title and text we are considering, and language uh, also we are considering. Let me revise what is happening. We got the data, we collected the data, okay. Once we get the data, we extract the features which are relevant for our model training. You this thing is also known as future engineering, machine learning word. So here we have captured the important features from the data that is required for our model training, and what model we are going to train first. This is content based filtering model, this is one, guys. Okay, so with this you can make a sense, we are collecting this video future all here. Okay, we now we have talked about the about future, and what about uh, user future, we will consider about the demo user graphics, and we will consider this contextual information. A demographic means age, female, gender, male, female, language, countries, year. These are demographics. Other things we will consider about this contextual information, uh, what is at this time person has seen this video, and all year, day of the time of the weekend where person has seen the video, mobile, on laptop, because on mobile the person will be watching more entertainment stuff, on laptop person will be looking to productive stuff. So this type of future are also relevant. Who we started a little late, so I will just try to complete. Yes, because a recommendation system is a little bit longer, so we will take latest time. Okay, guys, so you can see what we are doing. We are just capturing, the little future, latest time futures. Okay, now there are some fancy diagrams also, you can see. I will not go too deep into a fancy diagram, but I will give you some glimpse, so you can understand it is easy way, like what is it. And yeah, so suppose for this video, the future English video in duration, so no model doesn't take this data in a language in normal test, okay, from machine learning model. Even system, this computer system also understand numbers, okay, they don't understand your normal language test, okay. So even if you take the language test, they will convert it into numbers. So here this fancy diagram, we are just converting it into the model can understand, okay. So here English language, we are converting it into the numbers. Video ID, we are converting to this number specifically. Duration will convert in some number. Title, we are going to convert in some number, okay. So this numbers are known as embedding. This number are also known as embeddings, means like some numbers are some sort of sphere, like geometrical space. There will be some numbers, okay. So some we are going with these features, we are also just converting it into some numbers, okay. So contextual information also we are converting it into some numbers. This is user historical interaction, also we are converting it some numbers, converting into a some number. We are just combining it into a single array. So this will be single array. It will be like a single array, which will be having different numbers, 0 it to something like a data, means we have gone through this data collecting, then we have identified the future, we have converted into specific format in specific which machine learning model can understand. Now we can discuss the first model that we are going to train. We are going to train this content based filtering model, that is posting. So content based filtering model, as we know, that it going to match the user features, the videos features. So here I have written user embeddings video and embeddings here. So I told you as these user features. Here we convert these features into these numbers, and these numbers we totally combine here, and this combination here are calling then embeddings here. So these things embedding, or some sort embedding itself, we can say, okay. So these features, when converted into mathematical number, we are seeing it is an embedding, okay. So we got a user mathematical number, we are saying it is an embedding, okay. So we got a video embedding, okay. Then we are going to see like close our user embedding and video embedding is in, and specific tool is our neural network will help us, like which user and which video we are just getting closer, which user getting apart here. So it is try to just bring something close, user of specific video interest closer, and use of specific not having a specific video interest or more away. So let me show you the data set itself, so it will become more clear. So here the suppose here the data set that is going to this neural network, two neural network it is known as. So here we have got the user related feature and a video related feature. So when it is just having one as a label, one as a output, so guys, then it will happen in this case, when one is there is an output, it will try to make these things more closer in the space, into this embedding system, embedding space, we can say that geogrammatically a space here. So it will try to bring them more closer, it is one. So when it is 0, so in our like training data set, when we have it 0, so it will try to try to see. Okay, like these two vector, one is user vector, one is video vectors. There is a 0, so it will try to make this user and the user vectors more far apart. So if I just quickly show you, so here suppose this is a plane, okay, and here this is a point is having some sort of vector, this number we can say future number. Here we can see video, and this we can say user. Okay, here it will also some numbers. So now suppose it is this graph is initialized with this like type of numbers, but then this neural network is going to hold that similar ones together. Whenever this label is one, it will try to put them together. So during the training it will bring this here, this is here, it will try to bring this two more closer here, and suppose someone some number will be like let's suppose here is 0.2 and another user will be having 0.8 0.88. So it will just bring it more far to each other. So this is what is happening in this neural network. So this is for this content base, and in content base we are taking user features also, and we are taking this video feature also. But now if we see about this collaborative filtering, and collaborative filtering as we discuss, we will not take the feature. So here videos specifically user feature we will take. So here we are taking user feature, but in videos feature we are only taking video IDs, we are not taking the whole feature like here. So then like it will just try to make this specific video ID and specific user vector more closer so far, based on their the training the data set here. So that it will do, and the same type of thing happen like it will try to bring the coordinate more closer or far. And here just I just give you just overview again. So here the future are going to be those type of this future here, what is generative from here, and there will be encoders and defolders. Coders are just, you can just consider them as converting it into some numerical data. So then it is becoming some sort of user embeddings, and then it try to see which user embedding and which video embedding, which user feature, which videos feature are more closer and which are more far is, and it will try to make them closer by checking this label what is there in the training data set. Is this, I hope is this clear? Okay, just one last thing, then we can question and answer. So now in production we can use both methods like this collaborative content as I told. So suppose we have got this both neural network train, and then in production what we will do, suppose we are having billions of video. First we will pass it through this collaborative filtering, and then we will pass it through this content based filtering. Okay, there is some sort of thing you can decode, that is that we are passing from this content based filtering first. So here this candidate generation, this will be content based filtering. So why we are doing from this, so we are doing collaborative filtering first from billions of video, then for content base we are just passing thousand here from billions of video. It will get filter, then we will get thousand or one that we are passing to this content base what is as I told you in the starting when we discuss these pros and cons, so efficiency or performance, so this content based filtering method is slow, because we are considering all the future here, and collaborative featuring is fast. So if we run like on YouTube, suppose, or in Netflix, if we can run directly this content based filtering on billions of videos, it can it can it will be very slow, and the recommendation we want, here we load this page, how many second you wait, so we want it to become some short second type of thing is here. So then we will not pass all the videos base, we will pass them first, we will pass them to this collaborative filtering, that is candidate generation here. So from billions we will get the thousands of video from this collaborative filtering. And then for scoring we will also use this content based filtering matter, and then we will get the 100, and then 100 we will do some sort of a re-ranking model we use in production. That a re-ranking method just make sure that videos who are coming, who are actually going to the user, like 100 to dozen, they will shape like they will not be any sort of an article video, or not should be any sort of a clickbait of videos. Basic check is matter is just from 100, it will make some like 12 or 13 videos more relevant, which are safe also, which are not clickbait. Here this is some end again, but before that I can take a question and answer. So these guys who want to leave, I can leave.